Welcome back and thank you for joining me again. In this video, we will continue exploring the reciprocals of quadratic functions. This time, we'll focus on a quadratic function whose reciprocal has two restrictions. The graph that you should see here on the grid is a graph of a quadratic function g of x equals x minus 1 times x plus 3. As you can see, this is a quadratic function. It has two x-intercepts at x equals negative 3 and at x equals positive 1. So as we have mentioned in the previous parts of this lesson, wherever the quadratic function will have its zeros, the reciprocal would be 1 divided by 0, and the graph will produce a vertical asymptote. As a result, in this case, we will have two asymptotes. So one asymptote will be at x equals negative 3, and another one at the next x-intercept at x equals 1. Always remember to label the asymptotes by their equations. Next, we will discuss the shape of the graph of the reciprocal. Now remember that the asymptotes will divide the domain of the function, we're talking about the reciprocal again, into three sections. So negative infinity to negative 3, and then negative 3 to positive 1, and from 1 to infinity. So we will revisit each part of the domain or each section of the domain and see how we can reciprocate the graph of the given function gx. So as you can see in here, from negative infinity to negative 3, the graph of this parabola is going down. What that means is that when you reciprocate this decreasing graph, it will produce an increasing graph. So, and the way this is going to work, or the way we want to graph it, is by simply looking at some important points. So one of the more important points on the graph would be always the point where the parabola has a y value of 1, because when you reciprocate 1, then the reciprocal will be equal to 1. So this is going to be a point on the graph of the reciprocal as well. Now, the next point I want to reciprocate here is this one at x equals negative 4, y is 5. So at this point, the reciprocal will have a value of 1 over 5. So the way that this graph can grow then is by getting closer to the asymptote. Now remember that the smaller the y values become, remember, as we get closer to the x-intercept of the parabola, the y values are slightly above 0, say for example 0.001. So when you reciprocate 0.001, you get a number very large, comparably obviously, and that would be equal to 1000. So that means that the graph will increase, and the closer we get to the vertical asymptote, the greater the y values will become. And obviously the graph cannot intersect the asymptote, the vertical asymptote. Now, on the other hand, as the y values increase to infinity, then the values of the reciprocal will become 1 divided by infinity, and 1 divided by a very large number will be a number very close to 0, never 0, but very close to it. So we're going to say that the graph will approach the x-axis. This is where the y values are 0, but it will never cross it. Now, in a similar way, we're going to reason about the next arm of the parabola. So we're going to start with the domain 1 to infinity, or I should say continue with the domain 1 to infinity next. And that is because we want to see if there is any connection in the behavior of these two functions here, these two parts of the function here. So in a similar way, we're going to say at this point, y value is 5. The reciprocal will be 1 over 5. At this point in here, the y value is 1. It will stay equal to 1. The reciprocal of 1 is 1. At this point here, that's not a point, but as the y values increase to infinity, the values of reciprocal will become very close to 0. And we're going to continue drawing the graph this way, getting closer. Make sure that you make a smooth curve. I don't like this curve that I just drew here. So I'll make it look a little better. As you approach infinity for the given function, then the a reciprocal will approach 0, and we mentioned this in the previous videos, that would be a 0 plus, which indicates that it's slightly more than 0. And in a similar way, for these points where the y values get very close to y equals 0, then the reciprocal will become very, very large. So we're going to make sure that the graph goes nicely and smoothly, closer and closer to the vertical asymptote without touching it. And voila, this is going to be the arm of it. Now, as you can see, and we mentioned this for both these two pieces of the graph, that the graph will get very close to the x-axis, but it will never intersect it. So in this case, we say that the graph will form or will have a horizontal asymptote right on the x-axis. And the horizontal asymptote, if you want to label it by its equation, would be at y equals 0, we'll say. Now, in a similar way, we're going to reason about this section of the graph. And for this, we're going to use these 3 points first. I'm going to start with the point at the center. So here the y value is -4. That will make the reciprocal -1/4. So somewhere in here. Here we have the y value of -3. The reciprocal will be -1/3. In a similar way, -3 reciprocated to -1/3. And as the values of y here get very, very, very close to 0, but remember that we are in the negative y values, so the y values will get 0 negatives, meaning -0.0001. So as they get very close to 0, the reciprocal of a number of a negative number close to 0 will be -infinity. So that tells us that the graph of this function will drop down just like this. Get close to the vertical asymptote, never touching it. And the green graph, along with the vertical and the horizontal asymptotes, will represent the graph of the reciprocal of g of x. Now, if you were to check how the increasing and the decreasing intervals change in here or work together, is the graph of the parabola is decreasing, the graph of the reciprocal is increasing. Always remember, read the graphs left to right. The graph of the parabola is decreasing. For the same interval, the graph of the reciprocal is increasing. The graph of the parabola here again is increasing, the reciprocal is decreasing. And lastly, the graph of parabola is increasing and the reciprocal is decreasing. So let's take a look at the features of each graph again. So we have the x-intercept for the parabola at -3 and at +1. This is where the graph of the reciprocal will have the vertical asymptotes right at x equals -3 and at x equals +1. The y-intercept of the parabola is at -3. Now the horizontal asymptote of the reciprocal is at y equals 0. Now let's look at the end behavior of the parabola. So this is x approaching -infinity. Y will approach +infinity, and similarly, x approaches +infinity, y will approach infinity. It's an even degree polynomial function. Now, let's take a look at the behaviors of the reciprocal at its ends and at the asymptotes. So as x approaches infinity, here is x approaching infinity, the y values of the reciprocal will approach 0, but a little bit more than 0, 0 plus. And the same thing happens when x approaches -infinity, so the y values approach 0 plus. When x approaches -3 from the right-hand side, remember that the graph of the function will be right here. So that means that the values of y are going down to -infinity. And as x approaches -3 from the right-hand side, from the left-hand side again, so from the left-hand side, then the y values, as you can see, are approaching infinity. Now, next we have the vertical asymptote at 1. As x approaches 1 from the right-hand side, the y values are going up to infinity. And as x approaches 1 from the left-hand side, the y values are going down to negative infinity. Now, what are the intervals of increase and decrease for each of them? Well, let's look at the parabola. So from negative infinity all the way to negative 1, this is where the vertex of the parabola is, or the turning point, then the function will be decreasing. And from negative 1 to infinity, parabola is increasing. Now remember, we won't consider the turning point in either increasing or decreasing interval, and that is something that we will discuss by the end of this course when we talk about the rate of change. Now, for the reciprocal function, we're going to say that it is increasing from negative infinity to negative 3, and it is increasing from negative 3 all the way to negative 1. Then it will be decreasing from negative 1 to 1. And again decreasing from 1 to infinity. So as you can see, wherever the graph of the parabola is decreasing, the function will be increasing. And obviously here we have an interruption because of the vertical asymptote at negative 3. But if this weren't in here, then it would perfectly match the decreasing interval of the parabola. Now, in the same way, we can reason about the next function. You can try to do this on your own. I will continue doing this as quickly as we can. Again, here are the x-intercepts of the function mx equals x squared minus 4. And this is where the asymptotes of the reciprocal would be. I would draw the asymptotes and I would label them. One is at negative 2 and one is at x equals positive 2. So next I will try to build the graph of each function. Remember that y equals 1 is a very important point, so this is going to belong to the reciprocal as well, because you reciprocate 1, it stays 1, and same thing is going to happen to this point right here, and the same thing should happen actually at this point where y is negative 1 down here. So mark the points where this graph has a value of either 1 and negative 1, because when you reciprocate 1 or negative 1, it stays the same. Next time we'll reciprocate the y value here, which happens to be 5 again. So that would be 1/5 reciprocated. And this point right here is going to be 1/5 as well. This function seems to have an even symmetry. And now I will reciprocate all these blue points that I've marked on the graph. So we have reciprocal of negative 4 is a quarter. Reciprocal of negative 3, that's negative 1/3. And I do have my y value of negative 1 as well. And I know that as the y values become closer and closer, or get closer and closer to 0, so negative 0.00 something, the reciprocal will turn or will become negative infinity, bigger and bigger. And that's where the graph is going. Now, for this piece or shape part of the graph, we're going to say that then the graph will get closer to the vertical asymptote. As the y values approach infinity, the reciprocal will become close to 0. And as these y values also become positive infinity, the reciprocal will be close to 0. And as you can see here, the graph will get very close to the x-axis and never touching it, which means that the graph has a horizontal asymptote right at y equals 0. Now, let's take a look at the features of both graphs. So we have x squared minus 4 with x-intercepts at 2 and negative 2, vertical asymptotes will be at x equals negative 2 and x equals positive 2. The y-intercept of negative 4, but horizontal asymptote y equals 0. So these are not connected, only these two are. Okay, so wherever the x-intercepts of the graph are, that would be the vertical asymptotes of the reciprocal. So for the parabola, as x approaches positive or negative infinity, both ends will approach the same value, or value of positive infinity in this case. And now for the end behaviors of the reciprocal, we're going to have, as x approaches positive or negative infinity, the y values are approaching 0 plus. Now, if you look at the vertical asymptote of negative 2, negative 2 from the left-hand side, y is going to infinity. From the right-hand side, it's going to be to positive infinity, to negative infinity. So that's negative 2 from the right-hand side, and negative 2 from the left-hand side. And in a similar way, we'll determine the behavior at 2 plus infinity and 2 minus, it's to negative infinity. Increasing and decreasing intervals, you see that this parabola is decreasing from negative infinity to 0. And it is increasing from 0 to infinity, as you can see, from x equals 0 to infinity. So these are the values in charge of these increasing y values. So these are the values of x. Now, the intervals of increase for the reciprocal would be, this is increasing, and this is increasing as well. So we're going to say that it's increasing for x values from negative infinity to negative 2, joined by negative 2 to infinity. So as you can see, again, decreasing interval of the parabola became an increasing interval for the reciprocal, with one exception, the vertical asymptote. And the graph will be decreasing for x values from 0 to positive 2, joined by 2 to infinity. So as you can see, when you graph the reciprocals of a quadratic function, whether it is with one restriction, when you have only one vertical asymptote and you only see these two arms, or when you have two restrictions on the reciprocal of a quadratic, where you get those two arms that we get in the one restriction, but you also get something in between the two vertical asymptotes. Notice how the horizontal asymptote remained the same. And this is something that I discussed to more extent in lesson 2 of this unit. So it's already posted. So please visit. It is very important to learn and understand how asymptotes are formed, because it makes the graphing of the function of reciprocal functions and rational functions in general a lot easier in understanding, no matter what the degree is. The point is that in both cases, or in all cases that we have seen so far, the vertical asymptotes would be at x equals whatever the restricted values are. If they have one restriction, one vertical asymptote, two restrictions, two vertical asymptotes, and so on, whereas the horizontal asymptote will always be exactly at y equals 0. Now, our next and last topic with reciprocals of quadratic is the case when the quadratic has no restrictions. So let's take a look at our first example. So we have the function y equals x squared plus 0.5, and we want to build the graph of the reciprocal 1 over x squared plus 0.5. So I've drawn the graph of y equals x squared plus 0.5, and we're going to build together the reciprocal. Now, as you can see in here, this function has no x-intercept. So what that means is the y values will never become 0 no matter what x is. So that means that the graph will not have any vertical asymptotes. So what we're going to do then is try to build the graph by reciprocating the important points. And I marked 5 points on the parabola. So here the x value is 0.5. The reciprocal of 0.5 is 2. So this will be a point on the graph of the reciprocal. Now at this point in here, the y value is equal to 1. So that means that these two will be points on the graph of the reciprocal as well. At this point right here, we have the y value of 1.5. So 1 divided by 1.5 is going to be a smaller number. So if you go 1 divided by 3 over 2, right? So 1.5, that would be like 2/3. So somewhere in here. And as you can see here, in this case, we have even symmetry. So we can confidently just draw the same points on with same y values on both sides of the y-axis. Now, this point in here has the y value of about 4.5. So the reciprocal is going to be equal to 4.5 is 9 over 2, so 2 over 9. So it's going to be a number very close to the x-axis. And this point in here, it's not a point really, but this one here indicates that the arrow indicates that y is approaching infinity, which means that if we kept going, then the y values will approach 1 divided by a very large number, which we now know it's 0. And now in the same way, we're going to do this as well, the other side. Now we're going to connect all these points in a nice smooth curve. Now, as you can see in here, we're connecting these two together. Now, when the function decreases, this one must be increasing, but the decrease is not constant in a way. So what that means is that when you reciprocate this is going to make a little bit of a curve in here. So it looks like a bell curve actually, if you have gone through data management already. And this would be the graph of the reciprocal of a quadratic with no zeros. Now, notice how the graph of this function will never intersect the x-axis. The y values will never become 0, which means that it does have an asymptote, a horizontal one. And still the horizontal asymptote is at y equals 0. And I want to invite you thinking about why is the horizontal asymptote always at y equals 0. So keep an eye on the numerator. That can be a clue. Now, no x-intercepts for the quadratic, no vertical asymptotes for the reciprocal. The y-intercept for the quadratic happens to be at 0.5. We have a horizontal asymptote here at y equals 0. As x approaches plus and minus infinity, quadratic goes to infinity. And for the reciprocal, as x approaches infinity or negative infinity, the y values are floating just above x-axis, so they are 0 plus. Intervals where the function is increasing or decreasing, here is the function decreasing. The quadratic is decreasing for x values from negative infinity to 0, and that will make an increasing interval for the reciprocal. On the other hand, quadratic increasing from 0 to infinity will produce or will make a decreasing interval for the reciprocal, because increasing quadratic, decreasing reciprocal. Now, in a similar way, you can think about the next example where you're given the graph of negative x squared plus 4x minus 5. So this is drawn here for you. And you will have to determine the graph of the reciprocal. So the idea will remain almost the same. What you're going to see here in this case is, I'm just going to plot the points. So wherever the y value is -1, it will stay -1 for the reciprocal, right? And here the y value of -2 translates to -1/2 for the reciprocal. Same for the other point here, so -2, -1/2. As the y values approach negative infinity at both ends, the reciprocal will approach 0 at both ends. And that will form sort of the same graph as we had before. But this time, I'm trying my best here. It's always the left side and the right side never look the same. But we're trying our best. As you can see here, we have a horizontal asymptote. That will be the x-axis that this graph is not intersecting. And we're going to write the equation of it as well to label the asymptote. Remember, asymptotes are part of the graph. So we cannot actually say that we have drawn the graph without drawing its asymptotes. It's not complete because they transform with graphs as well. Now, next we are looking at the features of the function. So x-intercept for the quadratic is none. And vertical asymptotes, none. The y-intercept here in this case is -5. Horizontal asymptote here is at y equals 0 as always. Now let's look at the end behaviors. -∞ for the parabola and 0- we're going to say for the reciprocal because the y values of the reciprocal are getting very close to 0, but on the negative side on the of y values equals 0. So that's why we're going to call them the 0-. Now, wherever the parabola is increasing, the reciprocal is decreasing, as you can see. So that happens for x values from -∞ to +2. And the parabola will have, sorry, I made a small error that I have to, here we go. So I placed them in the wrong spots, that's all. So this is, the parabola is increasing from -∞ to -2 to +2. And the graph of the reciprocal is decreasing. So we're going to write it right here. And if the parabola is decreasing from 2 to infinity, the function is of the reciprocal of parabola will be increasing from 2 to infinity. So these are all the graphs of reciprocal functions. One thing that I want us to take away from all these from the entire lesson is that number 1, the vertical asymptotes again will always be at x equals restrictions, and if there are no restrictions in the, or no zeros for the parabola, there will be no restrictions for the reciprocal, and there will be no vertical asymptote. So asymptotes of quadratic functions with no restrictions, and when the numerator is constant, are none. But the horizontal asymptote will always be at y equals 0. So in addition to the lesson, I have created this reflection sheet for us so that you can write down the things that you learned. So after you watch the video or after you practice questions, but ideally after you learn a lesson, it is important to reiterate one more time, to go over one more time what you've learned. Learning is a complicated and a funny process. First of all, you have to know what works for you. But there is also a general, method of learning, which is you're introduced to a concept. You want to listen to it carefully to make sure you understand all the connections. And then you have to go over all the steps in a process on your own. And I'm talking about any kind of problem that you're solving in math or any new concept that you're learning. And once you have, or you think that you have understood the entire concept and all the connections and all the steps and how they work together, it is very important that you write down the rules that you've memorized, because that solidifies your learning, and that's what helps build thinking skills. Like, thinking skills are not built in one day. So they are built through patience and reflections. So there you go. As always, thank you for learning with me, and I will see you next time. You do have some practice questions in here. If you want to practice, you're more than welcome to. And you can stop the video if you want to continue with the practice questions, and you have the answers. Now, I also made a set of thinking questions for this lesson. Very interesting to do. I made quite a few actually, and they look similar, but they're not exactly the same. Every question will bring out something new. So please try them and see how far you can go, and think about the better or the best answers possible. You do have an answer key, but for the practice sheet in here. But if you want to actually test your thinking and test your answers, use technology, use Desmos to learn and understand them better. And as always, again, one more time, thank you for learning with me, and bye for now.